So yeah, I'm going to be talking about data science and astronomy, and specifically AAS 243 and ATDS 6, and I will define those acronyms as we go. And Kick, there will be some explosions in here, I promise. All right, so the American Astronomical Society, lovingly pronounced AAS, was founded in 1899, so 125 years ago, as of this year. And it's the American Society of Professional Astronomers and Related Individuals. Their mission is to enhance and share humanity's scientific understanding of the universe as a diverse and inclusive astronomical community. I'm guessing the diverse and inclusive part was not in the original 1899 mission, but look, we've evolved over 125 years, so that's great. That's good to have that in the official mission statement. There's over 8,000 members currently. American is in the title, so it's mostly US, but there's also quite a few Canadians. Yes, that is more evolution than NASA. I definitely agree with that. And quasi-quincentennial. Good word, Chutton. All right. So their main thing is they do a lot of stuff throughout the year, but there's two big annual meetings in January and June. The winter January one is the bigger one. And so last month was the 243rd meeting of the AAS, and it was held in New Orleans, Louisiana. It was one of the largest AAS meetings ever. They tend to grow a bit each year. Of course, like everything else, COVID kind of messed that up. But this year there were over 3,400 attendees. And the really interesting number that a lot of the AAS leaders talked about was 1/3 were first-time attendees. So this might be, younger undergrads or grad students that had never gone to a meeting before, or, over the last few years, people had done either stayed home or didn't have funding or things like that because of COVID or economics, things like that. So it was really interesting that such a huge fraction was first timers. So the meeting itself was 243rd meeting of the AAS, usually shortened to AAS 243. Like pretty much all of the AAS meetings, they had multiple keynote and plenary talks, dozens of sessions with hundreds of talks and posters. This is all standard every year. And it really does cover all aspects of astrophysics and everything related to the field. So any astrophysical research topic you can think of, there was probably multiple sessions. This includes aerospace, rockets, space travel, crewed and uncrewed space travel, education and public outreach of teaching science and astronomy, computing aspects of astrophysics, facilities, observatories, laboratories, diversity, equity, and inclusion. There's even multiple sessions devoted specifically to climate change, both astronomy observations of climate change and how astronomy as a field affects climate change. We fly lots of places to go to conferences. We have observatories that are in high mountains in the middle of nowhere. How does that affect the climate and the ecology? Kick, I guarantee that there was a talk or two on something involving time travel theory. So I bet that was in there somewhere. There's also splinter sessions and sort of meetings within a meeting within the main schedule. One of those is Astronomers Turn Data Scientists, which is what I will talk about sort of in the last half of the talk. There's also career-related activities, and these are for academic and non-academic related activities or careers. This includes panels, roundtable discussions, resume feedback, mock interviews, informal chats, all kinds of stuff. So that's a big piece of what the AAS does as an organization and at this big meeting. There was also an Astronomy on Tap event, which was an evening social event for the public with fun and engaging astronomy presentations. I gave one of the presentations. I'm one of the big organizers of Astronomy on Tap worldwide. We do events all over the world. I think we're in 100 locations, maybe 101 locations around the world now. And there's been 2,000 events or 2,002 events since 2013. So super cool. A large fraction of the cities that I know people live in have this for folks that are on the call. The most recent one that started just, I believe, last week was Vancouver. So for our Vancouver friends, if you didn't check that out, you should look them up on the social medias. And then, of course, you're in New Orleans, you got to experience the local culture. So for me, that meant eating and drinking a bunch. So beignets, Cajun, Creole seafood, and very fancy cocktails. So that was awesome. So specifically, I wanted to take a little bit of time and talk about some of the data science that I saw being used in astrophysics research. Most of these slides or most of these images are going to come from a single person, which feels a bit biased, but I actually had access to his slides, so it was easy to pull images. But these kinds of um, uh, these kinds of things are used I saw in a number of talks and presentations. And yes, Chutin, thank you for putting the astronomyontap.org website in the chat. Many of the locations have pages on there, and many of the events are announced on there, but not always. But we push them to do that. Okay. So one thing that I saw, this was people using PCA, principal component analysis, for dimensionality reduction and for searching for correlations and features that are, uniquely informative. So this gigantic, kind of cool looking plot is 120 observed and engineered features from an exploding star. So here you go. Here's an exploding star, or some images or some features measured from an exploding star. Patrick Alio is the astronomer I'm going to be stealing a bunch of images from. So this is cool. A lot of people are using this now, where they can, make a ton of observations, engineer a bunch of features, but then, as opposed to plotting X versus Y of every combination, you can use PCA, and it actually tells you pretty quickly, what's correlated, what's unique, what's interesting. Um, there's sort of lots of techniques, sort of standard data science-y kind of machine learning techniques that are, to help with creating data sets, cleaning data sets, stuff like that. So, if we have a rare type of thing in the sky and we want to try and detect that, you got to oversample the rare observations in your data set so you can balance your classes. SMOTE is a methodology that maybe some of the data science folks have heard of, that allows you to do this oversampling, so that you can kind of have a balanced number of classes inside your training set and when you're trying to put together a classification algorithm. This one is really cool. I've seen a bit of this over the last few years, but there was a lot of talks applying this to a variety of astronomy observations. So basically, if you just want to classify what the hell am I looking at really fast, you throw it through a neural net. If you want to classify something but understand why it got classified that way or trying to understand the physics, random forests are a bit more explainable and give you a little bit of an idea of the feature importance, a little bit more than the opaque boxes that are neural nets. And so this is yet another example of observing what ended up being a weird exploding star. But basically, you take a bunch of observations. Those are the green and red dots in the top chart. You're basically just measuring how bright is this thing over time, where the time axis, just like a time series, is going from left to right. You can throw each new observation into your neural net, and basically you get a probability that the thing is, quote, normal, and a probability that the thing is, quote, an anomaly or weird. And you can keep plotting those probabilities as you add more data. That's what's in the bottom chart. And then once you hit some anomaly cutoff, 0.5 or whatever threshold you want, you can send an alert automatically and say, like, hey, this is an interesting object. You can even trigger automated telescopes that will actually automatically go look at it and get more data because you think it's interesting. So I see Alessia is asking, when we say few observations versus lots, what's the scale of the numbers? Highly dependent on what we're talking about. So for supernovae, this is one supernova, one exploding star. And so you see we're getting, sort of each day, we're getting maybe 2 to 4 observations. And some days we miss it, might be cloudy, things like that. And so there's gaps in this time series in the chart I'm showing. But by the time, at least for this use case, by the time you can call it an anomaly, you've gotten however many green and red points are left of that vertical line in the top chart. So, maybe 20 or so. Some types of observations, you've really only got a handful, less than 10. And then like that PCA chart I showed, that's 120 features and engineered features from many observations, hundreds of observations of a single object. So it can vary widely, and that's a good thing, right? You've got sparse data sets, you've got very dense data sets, so you can use, you need to use a variety of data science and machine learning algorithms and methodologies, depending on what use case you're in. Does Patrick have a blog or notebooks? Good question. Yeah, if somebody wants to Google that, that's great. I will talk a little bit more about Patrick later in the talk. He almost certainly has a very good GitHub that has this stuff on it. I'm like 98% sure. So if somebody finds it, feel free to drop it in. But yeah, Patrick's great. And he'll come up more in the talk later. I want to throw in a little bit of DE that we hear about in astronomy. Here's a somewhat cartoony image of some of the data pipelines for LSST Rubin Observatory. And I'll get to that in just a sec. But basically, we need data pipelines for fast and efficient data transferring and processing for our observations. Yeah, Chetan, that's it. Patrick Aleo is his name, and I believe that's his GitHub. So yeah. So I wanted to talk as an example, the Vera C. Rubin Observatory. This is a huge project that's going to be starting in just a couple of years. It's a gigantic telescope that's going to be looking over the sky and observing the entire sky every couple of nights. So it will create 20 terabytes of raw data every single night. So what the hell do you do with that data? Well, you hire good data engineers to help us data scientists and astronomers deal with that. A lot of times for certain science cases, you need to process the data and clean it in near real time. Some of the data need to be analyzed on minute to hour timescales, like the classification stuff I was talking about a little bit earlier. Um, and then data transfer time requirements can vary, but all of the data do need to eventually go from the Andes Mountains in Chile, where the telescope lives, to universities around the world. So, this is, as one of my friends who works on some of this stuff likes to say, it is still most efficient to roll a DVD across a table. That is still the most efficient way to move data, technically, but that does not work when you're in Chile and you need to get data around the world. So there you go. All right. So something that I had never heard of before, which is relatively new, I think just new in the last couple of years, is this Astro AI initiative based at Harvard. And so I went to a little presentation from them. Their mission is, or their summary is that they're a center that develops artificial intelligence to solve some of the most interesting and challenging problems in astronomy. That's a bit of a fuzzy one, I'm sure, written by their PR people, but okay. So it's based at the Center for Astrophysics, Harvard and Smithsonian, which is a subset of folks at Harvard who work on all kinds of astronomy stuff. They're pretty well known. They get lots of funding, so they can do cool stuff. And they have students and professors from around the world. It's not just Harvard folks. They collaborate with and have funding for people from around the world. I think the really cool bit is they actually work directly with computer science academics from around the world and industry folks from some Boston-based tech companies. So it's cool. I've seen some results that they presented. They were interesting astronomy projects, but the connection with CS, the connection with industry, those are all things that I'm a big proponent of. And it's nice to see that you sort of pop up in a place that has a lot of funding, which is always nice. And I said there was a lot of career related activities. So some of the ones that I participated in and related to sort of tech company DS data jobs, there was a non-academic career panel discussion. There was only 4 people up there, and they were across a broad variety of careers. And so sort of the tech industry, aerospace, satellite industries, those were all sort of represented as all together by an aerospace engineer from Ball Aerospace. We had roundtable discussions, which this is a thing that happens every year. So 15 different careers, again, academic and non, each had a table and sort of Q&A informal chats. Unsurprisingly, the data science and aerospace engineering tables were the most crowded. The DS table had 3 working data scientists, including myself, and we had about 15 attendees for the hour and a half roundtable. And the range of people was pretty interesting: undergrads, grads, and postdocs, people just kind of interested in data science, all the way to people actively applying to data science jobs. Lots of informal chats during the AAS meeting with many people, a variety of seniority levels, all the way up to senior faculty, professors, which is cool. I got some requests to schedule like official time during the AAS meeting for resume feedback and mock interviews. Those sort of happen organically, kind of randomly, but people said like they'd love like a block of time for that. So that's something I might suggest next year when we're planning some stuff. As usual at these things, I get some invitations to give data science and tech career lectures at universities. I gave one at San Francisco State University a few months ago and have traveled a handful of places around North America to give this kind of talk. So that's always fun. I get to go see friends in other places and talk about this stuff. And in the last 4 weeks since AAS, about 20 people connected with me on LinkedIn from the meeting. 5 people sent me resumes to give feedback on. 3 people asked for one-on-one Zoom meetings to talk about careers. So this stuff sort of happens throughout the year, but obviously there's a big spike right after the AAS meeting. So on to another career-related event and something that I have a big hand in. This is what I'll talk about sort of for the rest of the time that I've got. Astronomers turned data scientists, or ATDS. It's really a loose-knit informal community that was sort of organized as much as you can call it organized in 2019. So the mission sort of statement here is that ATDS came from a desire to create a more cohesive community among former astronomers who are currently working in big data in industry, and between those former astronomers and current astronomers, especially those current astronomers who use big data and data science tools and techniques in their research, as well as those who might be interested in transitioning from academia into a data-related career. Do you think that's a bit of a wordy description? And you know me, you know that I wrote that because I tend to write a little verbose. And you can also see we have a link here to this year's ATDS webpage, and it is very old school retro for those who enjoy that kind of thing. And not on purpose, really, just because I write like straight HTML and a little bit of CSS, and too bad. That's what I do. Okay. So I'm a co-founder of ATDS and a current organizer. The main ATDS event is a one-day meeting within a meeting, which the AAS call a splinter session. That's always held during the big annual winter meeting of the AAS. It's sponsored by the AAS Committee on Employment. And in addition, we do occasionally get corporate sponsors. Thank you, Mozilla, who did sponsor our evening networking event, which I'll talk about at the very end of the talk. So that's very cool. And we haven't released it today yet, but we just started an ATDS podcast. The first episode came out last month. The second episode, I believe we're going to release this afternoon. We're on the YouTube, Apple Podcast, Audible, Podbean, Amazon Music, lots of places you find podcasts. So we're just ramping this up. We'll see how it goes. All right, the attendees and participants include different types of people, and this was sort of hinted at in the description of ATDS originally, but it obviously includes former astronomers working in big data, folks like myself and Julie. It includes academics that might be interested in these careers, academics that are actively looking for careers, applying or working on their resume. Also, academics that just are interested in these kinds of techniques that people are using in industry that they could apply to their research. And then the really interesting group that I really like when they participate and I really like talking to are the mentors. So advisors, professors, educators, even bureaucrats who want to learn more about these types of jobs and especially how to help their mentees prepare for such careers. Because sort of by construction, those people have not mostly had careers in the tech industry. So those are really interesting folks to talk to. I've been doing this for a few years, so people in the astronomy community will just send people my way and to other ATDS organizers and speakers when they have questions about or interest in such careers. This happens during the meeting, after the meeting. A handful of people came up to me at AAS and said they remember a career talk I gave or ATDS from a few years ago, which is always nice to hear. Some of them are using data science, machine learning techniques in their research, and many of those folks are actively looking at careers in DS. So it is sort of a long-term connection, which is nice. And this year, for the first time, people use the term ATDSing as a verb, or maybe, I don't know, what's the ing? I forget what that is, the grammatical form of speech. But basically, Jaren, thank you, yes. So the verb, I guess, would be to ATDS, meaning to talk to astronomers about careers in data science. So multiple independent people use that, and I thought that was hilarious. So it is now in my vernacular. A short history of our meetings. We started in 2019 in Seattle. That was in person only. And then in Hawaii in person. We had 2 fully remote thanks to COVID. Then the last 2 years have been hybrid, which is great because for the hybrid meetings, we are allowed to have anyone attend remotely via Zoom for free. So you don't have to be part of the AAS. You don't have to register for the meeting. You can just watch the Zoom. So that's awesome. And right from the beginning, Julie actually was involved. She gave a talk called Productive Data Science. I still have those slides. You can get them on the ATDS 2019 website. So feel free if you want to see an awesome talk from Julie from a few years ago. All right, so HDS 6 happened in New Orleans and on Zoom. It was our 6th annual event, hence the 6. I had to put that bullet in there because it made me smile because it's stupid. There were 3 organizers, including me. We had 10 talks total. So 9 were data scientists working in industry, and 1 was an astronomer looking for jobs, but he announced in his talk that he had just taken a DS job, and that was this Patrick Aleo. So he's like my golden boy of like the perfect situation here. So he's great, lovely human being, but we usually try to have 1 astronomer give a talk about data science techniques that they use. 4 of the speakers were in person, 6 were remote. Julie, again, gave a talk this year and was remote, and she talked about on building a fundamentally grounded key metric. That might sound like a familiar topic to a number of people in the meeting or in the call today. Speakers came from a social media startup, energy industry, aerospace, insurance, real estate, retail, logistics, someone from Apple, and Julie from Mozilla. So a broad range of types of companies and industries. And the topics were varied as well. We had a couple of talks on AI and ML at scale, data science techniques applied to some of these various industries, and a couple of talks on career stuff, both for academics who want to get into industry, to the tech industry, and also people already working as a data scientist. So that was nice. Here's a couple of pictures. We've got our official AAS meeting sign right there in the middle. One slide from a talk on using ChatGPT to basically read real estate documents and pull out like actual features and turn all of those horrific documents, if you've ever signed, mortgage paperwork kind of stuff with a notary, turn that into like a table that you can like learn about real estate. So that's cool. The picture on the right is from someone who made the transition from academia to data science just a couple years ago, with some of their thoughts and feelings on that stuff. Recording of all 10 talks, including Julie's, is online. I saw some speakers already share their recording on LinkedIn, which is nice. And so you can take a look at that. As Julie said, she'll probably present her talk as a data club at some point anyway, so maybe don't spoil yourself and look at that, but you can look at the other talks. Attendance-wise, we had about 25 in person, 15 on Zoom. We peaked at about 40 plus 20. Interestingly, the turnover was high. There's so much stuff going on at AAS. Literally, people are typically triple booked at any point in time. So there is a lot of turnover, people jumping from session to session. So I estimated the total unique was about 60. A little higher than last year for in person, which is nice. A little lower than it was on Zoom last year. So a little bit of a trade-off. But since we're one of the few AAS sessions that is recorded and posted online, we're hoping that a decently large fraction of folks will just be like, oh, well, I'm going to go to the in-person one here at AAS, but I'll go watch the recording later. So hopefully we'll hear from people throughout the year as they watch this and want to connect and have questions. Here's some pictures of the folks in our room. You can see we had some catering for breakfast provided by the AAS. So obviously I had to order beignets and they were lovely. Here's me in the front row with my Aloha shirt and my Mozilla backpack from the Montreal Hands. All right, 2 weeks after the event, we sent a feedback form out to all 210 people on the mailing list, whether or not they attended, and responses are actively coming in. So I just wanted to share a couple of comments. All right, thank you all so much for giving me the opportunity to be a speaker this year. It was a bit surreal being in the audience last year, wondering how to make the transition from astronomy to industry, and this year being on the other side as a resource is one of the newest soon-to-be graduates to transition to DS. This indeed is Patrick Alio, a brand new ATDS, so that was very cool. Someone who hadn't been to a ATDS in a couple of years filled out the feedback form, said the ATDS meeting I attended in 2022 was hugely helpful for me, and I'm excited to help others. So that was great to hear from someone who participated a couple of years ago, but is still connected and wants to help out, and actually told me he's interested in doing some organizing work in the near future. And another awesome quote: the wealth of technical insights and practical examples shared were invaluable, yet it was the speaker's collective exploration into the subtleties of career transitions, the transformative power of mentorship, and the vital role of community that truly surpassed my expectations. And this is a good friend of mine, Josh Miller, who's one of the co-organizers this year. All right, and then the last thing here, we have a tradition of holding an informal evening networking event. This year we held it at the Rusty Nail, which was a rad little kind of divey bar near the convention center in New Orleans, and it was sponsored by Mozilla. They provided some money for some drinks and food, so thank you to Auntie Mitchell for approving that. In theory, really Katie was the one Katie and Julie, so thank you to them. About 40 people attended. We had our own little like roped off section. We had some lovely local food. It was a very cool place. We had a good crowd. The college football championship game was on, so some people were into that. And again, here's me in my Aloha shirt, I'm sure with a cocktail in my hand that you can't see because I'm blocking it. But one thing I really liked was this sign, which I think is a very New Orleans way of saying a lot of what's in the Mozilla mission statements. So I'll zoom in here, and it says, all y'all are welcome, but you got to act right. And so with that very Mozilla and New Orleans sentiment, I'll stop and take questions.
Thanks, Jeff. Super interesting. And yeah, I love that as a little statement. I want that on a shirt or something.
Yeah, I walked in and I was like, oh, that is very Mozilla. I like it. Got to take a picture.
Yeah, it'd be a great sticker. Okay, cool. Late breaking news. I'm gonna try and keep the questions a little bit short because we have Jim Zhu, who's gonna do a surprise third talk, which is very exciting. But let's take a couple of minutes here. And yeah, if you have any questions for Jeff, if not, I have one. But yes, everybody, go ahead. All right, I'll ask mine. What about ATDE? Do you think there is interest in appetite for data engineering to attend?
Yeah, so that's a great question, and I didn't explicitly say this, and I should have from the jump when I talked about ATDS. I started ATDS because, or was one of the co-founders because everybody that started it was working as a data scientist with that in their title. But over the years, we've definitely broadened the DS part to be very broad. I sort of showed the initial the initial mission statement, but on the website, there's more description of like how it's sort of anything related to big data. So we've had people who absolutely consider themselves data engineers. Nobody that really considers themselves a straight software engineer, I would say, but definitely on the DE side that are building pipelines, that are building data warehouses and lakes. We've had people that are more classical aerospace engineers that are thinking about hardware, satellites, cameras, detectors inside of satellites. Sure, they might use data and write Python, but they're not really doing A/B testing or classification type stuff that are a little bit more classical ATDS. So yeah, ATDS has got like a little bit of a brand now. And the other thing is the vast majority of astronomy academics that go into the tech industry go into data science track jobs, at least as their first step. There's a couple people that are building these giant pipelines for these giant telescopes that I would absolutely say are going to be great data engineers. Like I said, there's a lot of people that have built, cameras and detectors at universities as their research for a telescope or a satellite that could easily go right into any aerospace engineering company. And I would consider those, more on the aerospace and hardware engineering side of things. So it's very, I try to think of it as a very broad umbrella. I think some people think of that way as well. I think we could do a little bit better of trying to broaden that. But it mostly comes from, the bias of the people that started it and run it, and the bias of that's the bulk of the careers that astronomy academics go into in sort of the tech industry.
Awesome. Yeah, that sounds great. Also, presumably the science part is interesting to everybody,
Yeah,
regardless.
yeah,
S unifies everybody.
yeah. I mean, using like Python and GitHub was like mind-blowingly cutting edge to astronomy researchers like 5 years ago, right?
Right.
Like literally that was unheard of. And now it's gotten quite common. And so that's great. Like that's a good thing. People should move in that direction, whether or not you're going to stay in academia and become an old crusty professor or move into data science, data engineering, et cetera. So